Yes, you are welcome to this other episode about functions. We are continuing and looking at the inverse of a function. This is Solomon at Solo for Math. Don't forget to subscribe. All right, what's an inverse of a function? So, an inverse of a function is that function that undoes the original function. For example, if you have a function f that maps a number a onto a number b, then there is a function that can take us back from b to a, and that is what you call the inverse of the original function. So the inverse takes us back to the original number. All right, so we represent the inverse of a function by this. If the function was t, then its inverse is represented as t power -1. All right, so let's look at examples to make this clear. How do we find the inverse of a function? Given a function fx as 3x minus 2, what we do is, first of all, we begin by letting maybe y to be equal to 3x minus 2. You can choose any unknown. Okay, like we forget about this fx or whichever notation is used. So we introduce in another unknown and then find ways of making x a subject of a formula, or making the unknown that you have the initial known. If it was y, then you make y a subject. Now in this case we have x, so we make x a subject of a formula. Okay, so what actually this one means is that x, okay, it means that like when we get the values of x and we substitute them in the function, it gives us this. So this is like the image of x. Okay, this is the image of x. So we need that function that takes us back from this image back to x. So what we do, let that function be y in this case, and then try to make x a subject of a formula. So I'll bring 2 to this side, so I'll have y plus 2 equals to 3x. So if I want to get x, I divide by 3 on both sides, and we end up with x as y plus 2 over 3. Now, that is not all. Remember, our function was given in x, so we have to take it back to x. So when we substitute, when we replace y with x in this function becomes, it becomes x plus 2 over 3. And then we say that that is our inverse of the function x. It is equal to x plus 3 over, sorry, this is a 2 over 3. All right, we'll look at another example. If you're given a function fx equals to 3 into x minus a2 over 4, we need to find the inverse of x. So we said start by letting that function 3x minus 2 over 4 to be equal to maybe y, any unknown. So find ways of making x a subject to a formula. So I'll multiply by f on both sides, giving me, or we could cross multiply. When you cross multiply, it gives you like 3 into x minus 2 equals to 4y. Okay, so when we open brackets here, we shall have 3x minus 6 equals to 4y. Taking 6 the other side, we have 3x equals to 4y plus 6. So if you want x alone, we go on and divide both sides by a 3. So by 3 by 3, it gives me x as 4y plus 6 over 3. So we said, remember this one and this, since they are factors of each other, or 3 can go into 3, or 3 can divide 3 to give you a 1. They cancel out, remain with 1, 1, giving you x. Yeah, so we said since our function was given in terms of x, we need to change this to x. So we just say that our inverse is equal to this function, but when our y is substituted with x, so it is 4x plus 6 over 3. Yes, I think we are good to go. Let's try out this other example. If our function is dx equaling to x squared minus 2, we said you begin by letting x squared minus 2 equal to y. Okay, so we make x a subject of formula by taking the 2 this side. So if we want x, we get the square root on both sides. So meaning our x is equal to square root of y plus a 2. But we said we want the inverse. This is actually the inverse. We just change the notation, and we also change this y to x. So our inverse of x is equal to the square root of x plus a 2. Yeah, that is the inverse of that function. One more example. If you're given fx as 3x plus 2, and you're also given dx as x squared, we want to find Roman numeral 1 df to power negative 1, and then Roman numeral 2 d inverse f inverse. So these are composite functions. We handle them differently. So Roman numeral 1, we want to get the inverse of this composite function. So the first thing is find f of x, okay? So that we have one function of this, and then we use the same procedure for finding the inverse. So this one we said is the same as d of fx. So meaning where there is fx, we substitute the function. What was fx? It is 3x plus 2. So from our function dx, which is equal to x squared, if you want to find d of 3x plus 2, wherever there is x, we put 3x plus 2 squared, and that is this is actually equal to the df of x. Okay, now we go on with finding the inverse. we said we let, now this is our function, this is our new function. We let that function, which is 3x plus 2 squared, to be equal to y. If it is y, then find a way of making x a subject. I'll start by removing this square by square rooting the two sides, equals to y squared, so that this square root goes away, I mean the square goes away, and we remain with x, 3x plus a 2, uh, giving us y squared. So take it to the other side, so we have 3x equals to y squared minus a 2. And then finally we divide by a 3 on both sides. Divide by 3 on both sides, and your x is equal to y squared minus 1, sorry, minus 2 over 3. Alright, so what is our inverse? So it means our inverse is, remember we've got our x as y squared minus 2 over 3. So our f inverse of x, not actually f inverse of x, we are finding g f inverse is equal to, so where there is y we put x, so this one will be x squared minus a 2 over a 3. Okay, Roman numeral 2, we want to find g inverse f inverse. It's a composite function. Okay, so it means we have this, for this one we have to first find the inverse of g, function g, find the inverse of function f, then we put them together and find the composite function. So what is g inverse? We get it from g. We have our gx was given as x squared. So we said we begin by let that function be equal to y. So if it is y, make x a subject by square rooting both sides. We have our x equaling to a square root of y. So meaning our g inverse of x is equal to, we change this to x, so we have square root of x. Yes. What is remaining? Remaining with f inverse of x, and we know we get it from a function of x, which is equal to 3x plus a 2. All right, so we said we let still our 3x plus a 2 to be equal to y. Then make x a subject. First take it to the other side, minus a 2. And when we divide by 3, we remain with y minus 2 over a 3. So meaning our inverse of function f is equal to, change this to x, x minus 2 over a 3. So when you have this, we can go on and find g inverse f inverse. Okay, and we say this is the same as g inverse of f inverse. So like you get f inverse and substitute it in g inverse. Okay, so it means if I further simplify, this will be g inverse of what was our f inverse, we got it as x minus 2 over 3. So if we are to remind ourselves of our g inverse of x, we got it as a square root of x. So if you want the g inverse of x minus 2 over 3, where there is x in this function, we put x minus 2 over 3. which is equal to square root of x minus 2 over 3. And this is actually equal to the G inverse F inverse. Yes, thank you for watching. In case of any question, anything you don't understand, any further questions, post them in the comment section, or you can send them on WhatsApp number displayed up here. Don't forget to comment, share, and to like if this content is useful to you. See you.